All right, so we are going to begin on Module 10 now. We did Module 8, Module 9, then we went back and caught Module 7. Now we're going on to Module 10. Module 10 is all about circles, different properties of circles, different things that we can do with circles. We're going to start off today talking about parts of circles, how to name them, circumference, diameter, and radii. We're going to try to keep it mostly along the lines of things that should feel familiar and then building on those particular ideas. So a circle is the set of all points in a plane that are equidistant from a given point. What does equidistant mean? Equal distance, same distance. So you pick a point, and then you go the same distance away in every single possible direction from that center point. And that is what defines a circle. One full revolution of a circle measures 360 degrees. A circle is named by its center. So if I had, let's see if I can make that bigger. There we go, got the wrong thing. If I had a circle like this, and the center of the circle was called point C, then we would call this either circle C, or you can draw a circle with the center in the middle of it, and then put the name of the center. So either of those would be appropriate ways of naming this circle. A radius is a segment that goes from the center of the circle to a point on the circle. So like this. This would be a radius. And I can draw line segments from the center to anywhere on that circle, and all of those would be considered, excuse me, radii. All the radii in a given circle are congruent to each other. So all of these little blue line segments that I just drew in here are congruent. A diameter, on the other hand, goes across the circle through its center. So something like this. This would be my diameter. We give it a segment name. So these points that are on the circle, I'm going to call the points A and B. So my diameter is segment AB. And if you notice, because it goes through the center, that means I have from the center to the edge on this side and from the center to the edge on this side. So this much right here would be the radius, and this much right here would be the radius. So the diameter is equal to the size of the radius times 2. So if I know the size of the radius, I can find the size of the diameter by multiplying it by 2. If I know the size of the diameter, I can take the size of the diameter and divide it by 2, which is the same thing as multiplying it by 1/2, and that would give me the size of the radius. A chord is a segment whose endpoints are on the circle. So something along these lines. I'm going to call this segment CD. Thank you, Ruby. A chord does not have to go through the center of the circle. My diameter does go through the center of the circle, and it also touches in two spots on the outside of that circle. So a diameter, my diameter AB, is both a diameter and a chord. And then the last thing that I kind of want to talk about before we move on to naming pieces of circles and trying some practice problems is this idea of concentric circles. Concentric circles are coplanar circles that have the same center. So I'm not very good at drawing circles, forgive me. But these would all be concentric circles. You don't have to have multiples of them, but it'd be a circle inside of a circle. I think it kind of looks like a target. All right. So before we go and look at some examples, big takeaways here, things that you definitely need to make sure to remember. All the way around the circle, if you start in one position on the circle and you travel all the way around the edge and you stop where you started, that is 360 degrees for one full revolution. The radius is half of the diameter. The diameter is twice the size of the radius. A chord, segment that touches both endpoints to the edge of the circle, and so a diameter is a special type of chord. All right. Let's look down at example number 2, and we will see if we can name some of the parts of this circle here. If you need to snap a quick picture, please feel free. All right. So number 2, the name of this circle. We said earlier we name a circle by what part? By the center. What's the center of this circle that's pictured here? X. So we could call it either spell out the word circle and then X, or the shorthand notation, you would draw a circle, make sure to mark the center, and then you would write the center's name next to it. So we would call this circle X. There are 4 radii shown. What'd you say? U, T, V, and Z. So those are the outside pieces. This is a segment name, so I have to give it 2 letters. So the center is always going to be part of that, but you're absolutely right. So XU with segment notation over the top. That would be this radius right here. XT, this radius here. XV, this radius here. And then XZ, this radius. Does it matter which letter we put or which order we put the letters in when we're writing that? No. Just make sure that the center is always part of the radius name because it goes from the center to the edge. There are 2 chords in the picture. RS and ZT, yes. RS, both endpoints are on the circle, and ZT, both endpoints are on the circle. What is the diameter? ZT. ZT not only goes from edge to edge, making it a chord, but it passes through that center X. Wonderful work. All right, now we get to the bottom of the page, and I apologize, guys. When I printed off these packets, the bottom of all the pages will have sections that are a little lighter. Not all the words will be hard to read, and it's not the same on every page, but the printer was having some issues. So there's like these waves of light printing on the bottom of every single page. All right, number 3. It says if TU from here to here is 14 feet, what is the radius of circle Q? 7. Radius is half of our diameter, and so the radius would be 7. We are going to go ahead and put units on that because they gave us the diameter with units, so 7 feet. Part B, now it says that LM, this right here, is 11 inches. What is the diameter? 22. The diameter is equal to 2 times the radius. So my diameter would be 22 inches. Fantastic so far. Let's go ahead and flip to the back side of this, page 2. Who can tell me what the circumference of a circle is? Distance around the outside, yes. This is the distance around a circle. So basically, it's the perimeter of the circle. The formula or the equation for the circumference of a circle, does anybody happen to remember this? 2 pi r, yes. Circumference is equal to 2 pi r. What did we say was the same as 2r? The diameter. So we could also write this formula as pi d. The radius is 2 times the diameter. So depending on what they tell me in the problem, if they tell me the radius, I'm going to use 2 pi r so that I don't have to do any extra work. But if they give me the diameter, instead of cutting it in half and then multiplying it by 2 later on, I can just use the diameter and multiply it by pi to get my answer. Speaking of, we got Pi Day coming up next week. Pi is the ratio between the circumference and the diameter of a circle. That is the official definition of what pi is, and that's why it has these non-repeating, non-ending string of decimals after the 3. So 3.14159 something, something, something. It keeps going on and on and on. And while individual digits will repeat, there is no pattern that happens to it. This is what you get when you take the circumference of a circle and you divide it by the diameter. And it comes out to be the same thing every single time. All right, let's look at number 5. Has anybody ever driven around a roundabout? What did you say? You've been to where there's roundabouts? So sometimes those are called traffic circles. They are supposed to be perfect circles. I know some of them are oval shaped, but we're going to work with a perfect circle shaped roundabout. A car enters a traffic circle and is 18 meters from the center of the island, which would be the centerpiece. That's what keeps you from just driving across it. So here's our traffic circle. Here's the center of it. And this distance here is 18 meters. If the car drives around the circle until it's back to its original position, what is the circumference of the car's path? So I'm going to write down my formulas for circumference. We can either do 2 pi r or we can do pi d. Which one makes the most sense to use here? 2 pi r or pi d? 2 pi r. Why? Because we have the radius. So c equals 2 pi times our radius of 18. Most of the time, when we are working with stuff that has pi, we want to leave it in its exact form, its perfect form, which means we don't want to put it in our calculator with the pi. Sometimes we do want the decimal approximation, so we're going to practice this both ways. If I have 2 pi times 18, the very first thing that I would do is multiply these two numbers together. What is 2 times 18? 36. So our circumference would be equal to 36 pi, and then I would need units with that. That would be meters. So if they ask for an exact answer, this would be my exact answer. Sometimes they want me to give it as a decimal approximation. Now I would take that and put it in my calculator. Grab your calculators for me. Come and grab a yellow one if you need to. We're going to put 36 pi in our calculators. We're going to get a decimal approximation for the circumference of this car's path. When you're putting this into the calculator, obviously we put the 36 in first, and then the pi button on my yellow calculators is located right here. It is 3 buttons below that green second key. When you hit enter, it will probably still have pi as part of the answer. How do you make it give you the decimal then? The arrow is right above the enter key. So 36 pi, and then we hit enter, and then you have to hit the button right above the enter key so that you can get the decimal. What does that give you? 113 point, give me 3 decimal places now. 097, and that would be meters. This is our approximate answer. Yeah, let's look at number 6. Many automobiles have customized rims that are attached to the wheels and align with the inner edges of the tire. The rim of a tire has a radius of 7.5 inches. What is the circumference of the rim? So I have my 2 formulas for circumference. Circumference equals 2 pi r, or circumference equals pi d. Which one should we use in this circumstance? 2 pi r. So C is equal to 2 pi times 7.5. So first thing we're going to do is we're going to multiply the 2 numbers together here, 2 and 7.5. What is 2 times 7.5? 15. So my circumference is 15 pi inches. There's my exact answer. Let's give our approximate answer as well. What is 15 pi in decimal form? 47 point, I heard 1, 2, and then I didn't hear the third place. 1, 2, 3, or 4, depending on how you round. This one should be rounded up. If you leave it as 1, 2, 3, I'm not going to take off points. Number 7, find the circumference of a circle that has a diameter of 27 centimeters. Which one would I want to use here? 2 pi r or pi d? Pi d. So I would have my circumference equals pi times 27. So my exact answer would be C equals 27 pi centimeters. It's the exact same thing I would get if I changed the diameter into the radius. So I divided it in half, and then I plugged it into this formula and multiplied it by 2. The radius is half the diameter is twice the radius. Let's put this into its approximate form. 27 pi is about what? 84.823. And let's stick some units on there. We've got centimeters. How are we feeling about these pieces so far? We good? Please let me know if you are confused anywhere. Yes. 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 You'll want to read the directions. If the directions aren't clear which one you should give, if it doesn't say leave it in terms of pi or leave it exact, or it doesn't say anything about rounding, you can decide which way you're going to give your answer back. On the answer key, if the directions don't specify, I'll give my answers both ways so that you guys can check yours. Sometimes the directions will say to leave your answer in terms of pi. That would be the exact answer. You would leave it like this then. Any other questions before we scoot down the page? All right, so far they've been giving us either the radius or the diameter, and we've been finding circumference. But what about if I know the circumference and I want to use that to find either the diameter or the radius? So circumference equals 2 pi r, or circumference equals pi d. What do we know on number 8? Circumference is about how much? 77.8. So where am I going to put that in my formula? In the place of C. We need to find the diameter and the radius, so it doesn't matter which one of these two formulas we use. Remember, they mean the exact same thing. One of them allows me to find the radius first, and then from that I can find the diameter. The other one allows me to find the diameter first, and from that I can find the radius. Which one do you guys want to use? 2 pi r? Sounds good. All right, so we have our circumference, which is 77.8. So 77.8 equals 2 pi r. What is the operation that's happening between the 2 and the pi? Multiplication. So to get rid of that, I'm going to use division. We're going to divide both sides by 2. What is 77.8 divided by 2? 38.9 is equal to pi r. What operation is happening between the pi and the r? Multiplication. So once again, I want to use division. Which thing am I trying to get alone? Pi I want by itself? I want r by itself. I'm trying to find the radius, so that's the thing that I want alone. So I'm going to divide both sides by pi. What is 38.9 divided by pi? 12.3, and then I didn't hear the rest. I apologize. 82. Do we need units with that? Millimeters. So 12.382 millimeters, that's my radius. They also asked me to find the diameter. The diameter is equal to 2 times the radius, And we just figured out that our radius is 12.382. So how big is our diameter then? 24.764, and we would put millimeters with that. Nice work. I want you guys to try number 9 on your own. We're going to check back in about 1.5 minutes.
Last unit.
Yes. What we start today. Yep.
Oh, what we start today is last.
Yes.
Okay. Thank you.
You're welcome. Do you guys want to do 2 pi r or pi d? 2 pi r. Sounds good. All right, so our circumference is 94.2 yards. So 94.2 equals 2 pi r. If you notice in the problem above, we had to divide by the 2 and we had to divide by pi. Since I'm doing the same operation twice, I can do that in one step. I can divide by 2 pi on both sides. That'll cancel my 2 out, and it'll cancel the pi out, leaving me just r. So we can do that in one step. What is 94.2 after you divide it by 2 and by pi? You said how much? 14.992. And we would put yards with that because we had the unit of yards on our circumference. And then to find the diameter, multiply it by 2. So I have 2 times 14.992. And that would give me a diameter of what? You said 29.98985, depending on where you rounded it and then what you stick into your calculator. That very last digit might be 1 away from what I put down, but that is totally fine. All right, let's do the last one like this. Number 10, find the radius and diameter of a circle with a circumference of 284 feet. So circumference equals 2 pi r, or circumference equals pi d. We've done both of the others with 2 pi r. Let's go ahead and do this one with pi d. So we have a circumference of 284 feet. So 284 is equal to pi d. Again, you can do this with 2 pi r. You're going to get the exact same answers for your radius and for your diameter either way. It's just which one are you going to find first. So let's do 284 divided by pi. What is 284 divided by pi? 90.4, and then it's got a bunch of zeros, right? So we're totally fine with just 90.4. Should we put units with that? Feet. So 90.4 feet is equal to my diameter, and then my radius is half the diameter, or the diameter cut in half, divided by 2. So I would have 90.4 divided by 2, which would give me what? 45.2. So the radius is 45.2 feet. Again, when it comes to circumference, it does not matter whether you use 2 pi r or pi d. If you use 2 pi r and you have the radius, just plug it in for r. If you're going to use 2 pi r and you have the diameter, you have to cut the diameter in half first before you put it into the formula. When you have the circumference, it doesn't matter either way. It just depends on which one you want to find first. You want to find the diameter first or the radius first. We have 2 more problems that I want to get through today. They're very similar, and they use the ideas that we've been working on here. So looking at number 11. It says the diameter of circle K is 12 units. Let's go look at circle K. Which one's circle K, the big one or the little one? The little one. And so we have the diameter, this distance right here, is 12 units. What else do they tell me? Diameter of circle J is 20 units. Well, here's the diameter of circle J. What are those 2 diameters doing? They're intersecting. They overlap a little bit. They overlap right here. Do we know how big that is? Did they tell me the sizes of anything else here? JD. So the distance from J to D, this distance right here, is how big? 8 units. And we are supposed to find EK. They want us to find this right here. All right, let's see what we can do to figure this out. If the diameter of circle J is 20, how big is the radius? The radius is 10. Can you name me another radius of circle J other than the one that I just marked? JE. Yep, JE. JE, which is a radius, is kind of cut into pieces over here. JE goes from the center to the edge of the circle, and these circles are overlapping. That's equal to segment JD plus segment DE. Do we know how big JE is? Do we know how big the radius is? Diameter is 20. Our radius is 10. Do we know how big JD is? 8. So 10 equals 8 plus DE. Well, that means DE has to be how big? 2 is the size of segment DE. That's not what they asked me for, but that's how big this overlapping space is. This right here is 2. Circle K, they said the diameter was 12, so how big's the radius? 6. Can you name the radius of circle K? KD. KD is a radius. And that is equal to what 2 segments added together? KD is what two smaller segments put together? DE and EK. DE plus EK. And how big is my radius, KD? How big is my radius? It is 6. Do we know how big DE is? 2. So 6 equals 2 plus segment EK, which means EK would have to be how big? 4. Let's try one last problem like that, because we got a lot of overlapping pieces there. The diameters of circle Y and R are 18 and 30 units respectively. So 18 goes with circle Y. If that's the diameter of circle Y, what's the radius of circle Y? 9 units. The diameter of circle R is 30 units, which means it would have a radius of what? 15. And then they also tell me what? WX is 6. So WX, this segment right in here is 6. That's the overlapping piece between these two circles. They want me to find YW, which is this space right here. And they want me to find XR, this space right here. Which one do you guys want to find first? YW sounds good. YW is part of the radius of circle Y. I know one of the radii is this, ZY. What's the other radii of that circle? YX. YX, which is a radius, is equal to what two smaller segments added together? YW plus WX, yes. Do we know how big YX is? Do we know how big the radius is? How big is it? 9. So 9 equals, do we know how big YW is? Nope, so I leave that YW. Do we know how big WX is? That is 6. So 9 equals YW plus 6, which means YW would have to be how big? 3. Right, now let's find that other piece, XR. Name me one of the radii of circle R. RT. Does that have any overlapping pieces to it? No. What's the other radius that it shows me? RW. So RW is the other radius of circle R. And RW is made up of what two smaller segments put together? You said RX and what? And XW. Do we know how big that radius is? Do we know how big RW is? 15. So 15 equals, do we know the size of RX? Nope. Do we know the size of XW? That is 6. So now I need to isolate XR, so I'm going to subtract 6 from both sides. So how big is XR or RX? 9. 9 is equal to RX. Or you could say 9 is equal to XR. It does not matter which way you put those letters. Very nice work today on the notes. That was a fantastic introduction to our study of circles. The homework that you guys picked up on your way in the door, that one is due on Monday. This finishes our entire first section of circles. Monday, we'll go over your homework and we'll start on section 2. Tuesday, we will finish section 2 in our Zoom meeting. I won't see you guys in person on Tuesday, but I will see you in a Zoom. We have like 24-minute Zooms, so we'll finish up anything that we didn't get to on Monday, and then you guys will have the rest of the time to work on any homework. You'll get a new homework on Monday as well. Does anybody have any questions for me? Please let me know if there's anything that you don't understand on the homework or if you have any questions at all.